Welcome back. This is going to be another mini repair session video. This particular video is going to be about these Dragonfly color changing LED solar lights that someone asked me to try to fix for them. This is the same person that I owe a couple favors for, so I have no problem doing this for them, of course. Now the problem is the top Dragonfly here just doesn't light up. Now the story goes is that this particular unit was dropped a couple times. If I pan up here, you can see this is the actual control surface up here with the solar panel on top, a little switch in the bottom, and then obviously there's the battery in there, the charging system, and either a controller or not. We'll get into that in a moment. And well, this has fallen off its hook a couple times, and that's why it no longer works. Like I said, all the other pieces here do light except the top one, so it shouldn't be terribly difficult to fix. My suspicion is that it's just disconnected. We'll see once we open it. Now obviously just have it up against a little background here so you can see these a little easier. But what I'm going to do is I'm actually going to reach over here and kill these lights one by one. I do have the power switch on, so these should come on once I kill the last light in here. Now you can see they all start off as being red, and then they'll go cycle into their colors, but they do it kind of individually. Also, they don't come up so bright right away, which makes me think that the battery just doesn't have enough juice in it. And that's something I can rectify either by letting it get some more sun, because it did sit here for a couple days, or I can just, you know, if the battery is connectable to, you know, like with alligator clips or something, I can just go ahead and charge it with my power supply here on the bench, and that'll be fine. But anyway, I'm going to go ahead and start kicking some lights back on over here just because it's a little dark to see. The eyes do it a little bit better justice than the camera does, but that goes without saying. I'm going to go ahead and just get the rest of the lights on here, and I'm going to take this down. We're going to put it on the bench and start poking around and seeing what we can find here. Alright, the top side here, of course, like I said, reveals the solar panel, as you can see. This does look like it has 4 actual individual cells that are linked up together. On the back, nothing special, just a power switch and 3 screws. Alright, grab my screwdriver and remove the 3 screws. And maybe I'll switch this off before I open it. Now, is this going to come straight off? It looks like it will. And what do we have inside? Well, we can see here, without getting tangled up, pardon me, the solar panel up on the top here, and they did a reasonable job of sealing this up. This looks like it's actually just hot glue that they use to seal it. On the other side over here, we do have a typical battery. Let's see what this is. It's a AA 600 milliamp hour 1.2 volt battery. It just says it's a rechargeable battery. It doesn't say what it's made up of. I can't tell if it's oh no, here it is. It's nickel metal hydride. Okay, well that's to be expected. Of course it says not to short it or anything like that. Yep, that's standard. And it's from Shenzhen Up in Electronics. Of course it's from Shenzhen. But it's good because it's a standard AA battery. Perhaps if I can get a hold of some nickel metal hydride batteries, maybe I'll replace it for her. I'm going to put that to the side, and perhaps, like I said, we'll connect this to a battery charger here. Over here, we can see the little controller circuit, which there's a 4-pin device here. Not sure what that is. Can't really see it. It's actually blank. There's nothing on it on the back side. Let's see the other side here. Oh, that has something. It's 52B, and then below there's number 1316. So we will take a look at those numbers in a moment, and I'm sure I'll put something up on the screen, maybe over here, when I find out what that is. And we can see that the wires that come up here, this is actually very similar to the wires that they use in headphones, where there are actually 2 wires in this one little strand here, and they're all just bunched together So my instincts were right. These are actually just hooked up in series, it looks like. And you know, so whenever this controller kicks in here, they'll just automatically come on. Now oddly, it looks like they just, let's see if I can zoom in here. It looks like they just actually connected all the wires together, you see right here, and then just soldered it to the actual pins, and then just left the little trailing pieces out here, which is good and bad, I guess. The bad thing about it is we know it's not the connection up here, because obviously if one works, they should all work, because the way they're connected, they're not like, it's not like they're in individual pads. So I mean, that makes my job a little harder, because now I have to see if I can get into the light and see where, if it's up there. The other side of it is, it makes it a little easier, because I guess I know it's not up here, right? It could be shorted out. I mean, that's a possibility, but it looks like these wires are actually enamel coated, so you'd have to get the lacquer, I should say, lacquer. You have to get the lacquer off first before you can solder them. Well, while I'm in here though, I will trim those nasty leads just kind of sticking out in the air. That's not necessary at all. I mean, there's nothing in here short out. It's just sloppy looking. But yeah, it's the shorter one that's not working, so I have to see which one it is. It looks like it's this one. Now it could be just the actual LED that's shot. It could be that water got in here. It is kind of rusted looking in there. So we could see if we could pop this out. Oh, yep, that's it. The LED completely corroded. That's the problem right there. This is just hot glued in, and it looks like they might have epoxied the LED into place. If that's the case, it ain't coming out. Quick explanation about what that does. LED, I don't have one handy. Oh, actually, I'm sorry, I take that back, I do. LEDs come in these clear little packages, which the plastic that these are made out of is very similar to an epoxy from what I understand. And if you drill a hole in one of these and then you actually put some epoxy in there and then stick the LED directly into it, then what happens is, it'll actually become one, if you could say, with the unit that you're gluing. Those two plastics kind of meld together, and I think once you do that, you ain't getting them out ever. So in this situation, what I'm going to do is probably just drill that right out. Just pull this piece of metal out here and just drill it out and insert another LED. Now, problem is I don't have any color changing LEDs. I only have regular colored ones. So if I want, I could re-engineer this and make one an individual color, and then I can deal with the resistor up in the top, or I could just leave it as is. Now the interesting bit about this is a 1.2 volt battery in here, and that 1.2 volt battery, as you can guess, puts out 1.2 volts. Well, LEDs, they run around 2 to 3 volts depending on the color. I mean, these may be special purpose LEDs. I'll have to do a little bit of poking around on the internet here and see. They may run at a lower voltage, or this circuit up here is bumping up the voltage. Now there is looks like a Xenia diode here. Obviously there's a capacitor, and this may be an inductor, so this may actually be a little like step-up circuit. I'm going to put the meter to this in a second here and see, and we'll test out the voltage of the battery. I should take a look at these other connections here and just see what the deal is. Maybe the other ones are starting to rot out too. I mean, they all light up, so I guess I should just leave well enough alone. But you can clearly see that one rotted out pretty well. So let's see what we can figure out about all this. All right, first thing I want to do is see how much voltage is on this battery. Now, like I said, keep in mind this thing hasn't been charged, so I'm assuming it's going to be low. I show this as being actually 1.220 volts DC. That sounds like it's spot on, but I feel like if it was fully charged, it should be just a tad bit higher than that. So again, we'll just set that to the side. I don't have an actual battery tester, and I will make a quick point about battery testers versus actual meters. Meter will tell you the voltages of the battery, but that's not under load. That's just what's on the battery currently, just as is. Obviously, once you put that into a different device, and of course, depending on what the device is, it's going to have a different result. So investing in a battery tester is actually a good idea. It's just one of those things that just never really had. My dad has them, obviously. I just never really grabbed one of them because I just, you know, figured batteries die and you just throw them away. I don't really need to go messing around testing to see if one's working or not. But at any rate, I'm going to go ahead and throw this battery into this holder over here. It's slightly off camera. And I'm going to go and connect this to the actual little pieces that are jutting out here that I haven't cut off yet. So they do have some kind of a purpose right now. And we'll see on the meter what kind of power we're dealing with. Now it shows right now it's just a negative 2.3, so that's nothing. The solar panel is right up against something. Oh, of course the switch is off. Let me turn that back on. And it's putting out 2 volts. So yeah, there is a little mini step-up circuit there that's of course bumping up the power to those lights. I don't know if you can see them. They are lighting up. Perhaps if I kill the camera lights here a little bit. I apologize for the squeaky chair. I do have a couple swivel chairs in this room. This just happens to be the one at this desk. It's one of those ones that don't recline, and there's a long story about this chair which I'll save for maybe another discussion. But anyway, it's just what I'm using right now, and unfortunately if I move my body weight around too much it does squeak. Now we can actually see sometimes this voltage jumps around quite a bit. Maybe if I get this closer up. Depending on what color it is, it depends, you know, obviously it's drawing more juice, but it seems like that's fluctuating. I did actually see it go all the way up to 2.0 at some point here. Yeah, it's getting close to that now, and it seems like whenever it's in the greens and blues, that's when it gets to the highest. It actually it gets up to 2.5 at one point here. So it's kind of interesting to see how that works. It probably has something to do with the amount of current it takes to produce each color. It's probably you know, something along those lines. The load's changing as the color's changing. Now I just I had a slight epiphany as I was looking at this. I actually have some of those cheapy dollar, you know, solar lights that you stick outside in your lawn. I actually revived one of those. I don't know if I shot a video of it, honestly. It was a little while ago now. And I just drained my pond out and found one of them living in the bottom of the pond. There's this little toddler kid that comes into my yard and likes to rip them out in the grass and throw them in the pond and, you know, leave them all over the yard. And it's kind of a pain in the neck. But I found a couple of them actually already in there. One was just kind of within reach because the pond has different layers. And then the other one was actually at the bottom of the pond. And it's now that the water's been drained out of it, I can actually get to it. So they actually work a lot of the times, though the battery ends up getting shot. And they don't use a standard AAA. It's like one of those like 2/3 AAA, which is just shorter. And the thing about them is they're not really that reliable afterwards either. The solar panel gets all wet, the charge circuit gets all wet. It's just something I don't think will end up working for me, especially since it needs a new battery. But the LED does work. So I might just grab one of those and sacrifice the LED out of it to put it in here. So with that, what I'm going to do is I'm going to go ahead and I'm going to inspect the rest of these just to take inventory to see what I need. And I don't have any other tools to really work on this at this particular desk because I do need to drill out this LED that's in here now if I want to replace it. And I have to get some epoxy because that's the one thing I don't actually have any of. I did use up what I had. So that's one thing, you know. The other thing I'll show, if I can get the camera zoomed in on it, hopefully, is wire that they use here is exactly what I thought it is. It is that type of wire that they use in headphones. You can see it's just copper lacquered wire, and you have to remove the lacquer if you need to solder this. And there's two different colors of lacquer to indicate the polarity of the wire. Nothing special. They do that just to keep the wire nice and thin, which is nice. And it is, after all, just an LED at the end. So let me go ahead and break the film now, and we'll come back to it once I have the proper tools and parts I need. I did a little bit of poking around after I ended the footage from the last little segment here, just to see if this thing still does actually work, and tried to get some tests on what the actual voltage of it is, and you know, that whole thing, so I can find a replacement. And it does work, like I mentioned. I can't solder in here because unfortunately, you may be able to see, there's only one lead left, and the other lead is so short, I can't get in there. But I can demonstrate how it works. And the interesting thing is these are red, green, blue, and the chip on here actually will display 7, I believe, different colors. And that's great, but the problem is depending on how much voltage you feed these things depends on if you get to see all those colors or not. It basically has to do with the forward voltage of the LED. It's a range between 2.2 to 3.4, if I remember correctly, from the ones I've seen on eBay at least. It seems like the red one, and that's just, it just goes without saying with just red LEDs in general, that they run on a lower voltage. That's where the 2.2 is. And then obviously the green and blue could run at 3.2 to 3.4 about. So in one instance, if you're running this at, let's say, that 2.2 volts, you're running one LED fine, but underrunning the others. And when you underrun them, like red will come up, and then green, and then blue, and then it'll go like red blue, which will give you purple. But as that color's starting to come up, there's just not enough voltage to run both LEDs, so one ends up winning out over the other. So you end up getting just red, green, blue constantly cycling through. And I'll demonstrate that in just a moment. And I guess that's the one caveat, because after all, it's a 1.5 volt battery. Well, at least in these globes that are. I brought this one in from outside. There's actually two here. There's a white one and a multicolor one. And then there's one here that I took to pieces. The white one was found in the bottom of my pond. I told you, I may have said in another video that one of my neighbor's kids decides to, a young little kid, so I can't really be mad at him because he doesn't really know any better, but he comes into my yard, grabs these, and likes to leave them in random places. And this one's white, all the other ones are multicolored, and we just didn't realize the white one was missing one day until I cleaned the pond out, and it was sitting in the bottom of it in the muck. And you can see it's pretty filthy inside. There's all kinds of particles in there, so it does have to be taken apart and cleaned, but it still works, believe it or not. And it was underwater for, oh god, a couple weeks at least. So it's interesting. The other one here, obviously, this is the put together model, and this is the one I took the parts. This one was also found in the pond, just not as deep. It was up in the clear water part of it, and it still works as well. But I wanted to see how it worked, and also it gave me a chance to clean it. But I'm going to sacrifice this because it was $1 anyway. We're going to use the LED out of it. But I wanted to test it to see if this LED is the same one that's indeed in the Dragonflies, and it is. So that's going to be good. That's one less thing I have to find. I just have to, like I said, drill this out. Now it does look like it'll fit. It's right about the same size the old one is, so that's great. Just have to get that out the way. This one runs on a AAA battery. We have some outside. I don't have any here, but they run on a 2/3 AAA, which is exactly what it sounds like. It's a AAA battery that's got a third of it cut off, and it's that shorter version of it. They actually sit up in the bottom of the battery, or that one's the electronics are up in the top of it, and then the actual globe, it's a plastic, just sits along the side of it. Where this one's the globes, all the electronics sit down the bottom, and they can put the battery down in here. Now it's you know, it's not waterproof, so I'm surprised they still worked, but that's neither here nor there. We're just going to go ahead and sacrifice it. Now, this is actually the same circuit. Inside here, you can actually see there's an inductor, a Xenier diode, a capacitor, and on the other side, a little IC that's covered over in epoxy here. And then, of course, the LED and the solar panel, and that's fundamentally it. simple circuit. Now this is obviously taking the solar rays here, and when it detects that solar coming in, it sends that voltage right to the battery, and obviously not the light. But if you actually take the battery out and put this up to the LED light here on my desk directly, you know, really close to it, it will draw enough power directly to power this light, which is pretty interesting. But you know, obviously there's no load to power the battery, so it has to go someplace. But the IC there, it seems like this is a buck converter, or I should say a boost converter, because you're actually boosting the 1.5 volts up to a voltage that's high enough to fire all those colors. But remember what I said, you're not getting all the colors that are available, you're only getting certain ones. And I confirmed this by just playing around here, and I'm going to replicate that experiment. All right, what I did is set my little power supply here to 2 volts, and it's set to 20 milliamps. Now if I connect the Dragonfly up, we can see this black alligator clip here is connected to the negative lead of the LED, and then since the positive is missing, I have just this long wire here, and this is just a piece of spare, just crimped wire, just, you know, a little snip of wire, and that's just being kind of held in place by my helping hands, and then I just have the positive lead clipped to the metal of the helping hands, just to, you know, keep it easy. And if I go ahead and turn that little power supply on, you can see it starts to glow red, and then the red will start to fade out, and then it just pops and disappears, and then you get nothing. And right now it's trying to actually display the red, the green and the blue, but they don't come up, and then it goes back to red again. Now during this particular red, you should have one of the other colors on here, but you don't. Now if I actually go ahead and raise the voltage, now my little power supply here is set to either current, constant current or constant voltage, depending on what's being drawn. Right now it's lower, the current draw is lower than what I have it set for, but the voltage isn't. It's actually drawing more voltage than it needs, so it's limiting it at the 2 volts I have it set for. So if I start to raise that up, we're going to take it up to, let's say, 2.5, and we can start to see that the colors start to come out a little bit now, because we're at the minimum voltage that the blue and the green need to show. So you can actually see it kind of looks a little white on the camera, but I assure you that's just because it's trying to mix some of the colors together. Right now, like, so that's pure green, and then it's going to go into blue, which is very, very dim, because blue needs a lot of power. And then it has like this kind of green red mix, and then this is supposed to be like a green blue mix, and then it should go into back to red. If I take this up now and raise this up, now you can really see the color come out vibrantly. Now it's starting to current, it will go between constant voltage and constant current, because I'm right at that threshold between some of the colors drawing more current than it's set for versus drawing more voltage. But you can see now it's more like a 7 color effect. Now you're starting to get the full green plus blue, green plus red effect. So you'll start to see like there's a nice purple. It should go into like that aquamarine colored blue, and you know, it's just going to keep going on like that. And I'll try to do this smoothly. If I zoom back out here and zoom into my little power supply, you can actually see where those numbers are just, you know, fluctuating here as it goes through the different colors. And this is just you'll see here, if I change the setting on this, the actual amperage, it's drawing, it's flicking back and forth between volts and amps, by the way. So this is 3 volts, and that's 0.007, so it's 7 milliamps. 9, 11, 13, 15. See, it climbed up depending on the color. Now you can, this has a bunch of different settings on it. Just by holding the OK, we can get the scroll like that. I really want to just display one of them. If I turn it off, we can do it. At any rate, now that we've confirmed what the power rating of this actual LED is, we can go ahead and play around with some of the other ones, which is what I did. So I'm going to go ahead and just disconnect this, and we'll grab our other little LED here, noting the polarity. And I'm just going to leave this right in circuit with everything else. And you can see there's the red and the blue, the green. And this is set to the same setting we had before, so it's giving us the pretty much same color pattern. And you see almost that's white. White is obviously all the colors mixed together. I'll kill some more lights here, maybe get a better effect for that. Yeah, they're quite simple lights. Everything is built right into that chip, so there's minimal that you really need to operate these things. You can just operate them right off the power and just have it go through. Incidentally, I should point out, if you do happen to purchase these things on eBay, you should be very careful because they actually have them listed as either being a slow flash or fast flash. And the fast ones are, exactly as it sounds. They're, like double the speed of this. Try to break out the macro lens and see if I can get a close-up in on this actual LED. It did actually manage to pop straight out, which was great, but I wanted to try to highlight actually showing what the chip inside here looks like. You can see, maybe you can see that there's a little chip and 3 dots right above it, and that's all sitting on top of what looks like the cathode end, and the anode is this little dot over here, and that just connects over to the chip, and the chip connects over to the actual lights themselves. You probably can just slightly make it out. You have to, blow it up. It probably looks better on the big screen than it does here on this actual little tiny screen I'm working with. But you can see it, to the naked eye. If you glance at it hard enough, you can see there's a little tiny, like rectangular chip inside there, and then the actual dots that emit the color. Pretty neat. But I was surprised that just pulled out. I just tried just popping it out with my pliers just to get the lead out of the way for the drill. Unfortunately, it is smaller than the new LED we're going to put in there, so I still do need to drill out the plastic. I just need to widen it a little bit. Also, they just jammed some heat shrink glue down the bottom of it. Hot melt glue. Just put a big bead of it down the bottom. I'm assuming that was to kind of diffuse the light a little bit so it's not so bright, but we'll experiment with that when I get the larger one in. I also have some round files here. I might just file out the inside of this here since the drilling may be a little hard to do. Haven't figured it out yet. Have to see how the plastic reacts. We're going to go with a 7/32 inch drill bit. Plug a hole right into that. Just go really slow and steady and we get the hole. Very easy. I'm just going to go ahead, instead of putting epoxy in this, they already used hot glue. I'm probably going to make the hole just a little deeper, and I'm just going to put a nice bead of hot glue right over the back of this just to connect the two. It's not like it's got weight to it. It's very light. It should be pretty easy, but I will drill that hole out just a little deeper just to get that to fit better. That's it. It's fundamentally it installed there. I left just a little bit of the color on the wires here, so it's just easier to mark it. But if we want, we can actually go ahead and hook this up just to see how it looks. Just as we expected it. So now I'm going to go ahead. I'll get the hot glue gun heated up, and we'll get the wires cleaned up on top of that unit, so we can just go ahead and solder it in, and also get the soldering iron plugged in. I actually was able to just take this tip of the soldering iron and heat it up to the end of the wire here, and just with a little bit of solder, it actually, the heat melts the coating that's on there, so that's perfect. So just pre-tinning those leads is going to do it for us, and then I can just connect the LED. Here's the end result. You could see I have them all lit up in a semi-darkened room, and unfortunately, from cutting the wire, you can see there is a little bit of a gap between these two. Not really too bad. There is a gap there, but it's not bad. I don't have any wire to replace it, so it's not like I can actually make them all perfect. And you can kind of see how they do that random kind of color change. But it does work. It does work, and it works quite well. In fact, I did actually have all these kind of synchronized at once if you turn them all on that way. One thing to mention, I couldn't cover this with clear heat shrink because I don't have any. I just used the black. just because it's what I had. But it's fine. You know, it's going to be used at night. That's when they come on, and you don't really notice it. Now you can kind of notice that this whole set kind of shimmers and changes color all at once. That has something to do with the actual controller circuit. I'm not sure what's going on there. And don't forget, this thing's been sitting inside for a while, so it's not exactly like it's running on a full battery. I did put that battery on charge a little bit, just for maybe about half an hour, just on a low, like on a low current charge. So it did get some power to it, but nothing spectacular. But anyway, that's all I really wanted to show for this video. It's a little longer than I wanted it to be, so I do apologize for that. Next video, you know, should have a few of those coming up soon, so we'll see you then. Thanks for watching.